Okay, we're gonna get started. It's a little after 1:30. Hello again. This is Wayne Bowen. I'm the Recycling Program Manager for the Pennsylvania Recycling Market Center, and welcome to the Sustainable Materials Management Webinar Series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. I will serve as your moderator today. Today's topic is business fundamentals for compost operation. And this is our second webinar of a three-part series. Um, we did our first webinar last month, which we recorded, and it is available on our website, on our webinar library tab. The second one here is today, obviously, and then the third one will be in August, on August 19th. So Jeff Gage is our presenter. He's with Green Mountain Technologies, and he's a certified composting professional and a wealth of knowledge in the composting. He's designed or upgraded and/or operated over 70 compost facilities throughout the world. And so he also received the 2022 Lifetime Achievement Award by the new U.S. Composting Council. So I'm going to hand it over to Jeff, and he can get started. He has a lot to cover today, so we'll get started.
Yeah,
Thank you.
we do. Well, thank you very much, Wayne. Appreciate you all attending on this round two. Hopefully your sound is better and the information that you're being given in this part gets you a little better idea of what's going on to make money in this project, to put forward your best efforts and understand with a clear head what you're up against. We're going to dive in deeply into compost recipes. There's very good reasons for this. It sets up everything. So while that might sound a little nerdy, it's quite important for everyone. We're going to look at the handling of the different materials that we have to get. We're going to look a little bit at the process flow, how to set up and receive materials, how to store it, how to actually manage it through the process. We're not going to talk too much about the composting types. In fact, this is in general for all types of composting. We're going to look a little bit at mixers and the equipment, depackagers, kind of setting up watering, setting up grinding, and then talk a little bit more about how we're handling materials, going through processes, how this might impact odors, your product quality, and actual costs. Then I'm going to try to save about 15 minutes at the end for a Q&A. So let's dive into the feedstock issues. We need to understand that the primary feedstock is not your only feedstock. There's going to be something else with this, typically because alone, things don't compost as well as they could if they're better blended. So we're going to look at issues that allow us to dive deep into what these feedstocks really should be. So pulling from the composting handbook, I put together these two tables into one table. So you get an idea of kind of why people aren't too worried about this. But if you can get into a preferred target range, your performance is going to be better during composting, your odors will go down, and your product will be a better quality product. All three things drive the bottom line of your composting. So in bulk density, that means how much fluffiness or what does it weigh per cubic yard or meter. We're looking for about 700 to 1,000 pounds per cubic yard. I like to have a target so that when you use a recipe maker, we actually get some of this cushion that we could have as long as it's under 1,200 pounds. It's still going to work. It might not work as good. Under free airspace, which is the kind of the part, if you filled up a bucket of compost and then added water to it, it's the amount of water that you can add to it that fills up the available free airspace. We want that to be at about 45% to 55%. So there's good density and good connection with the materials, not too much free airspace. Like for instance, a biofilter would be over 60%, would be ideal for that. But in a composting scenario, 45 to 55%. Moisture for me is number one. trying to keep it between 50 and 60% during active composting, all the way up until the time you want to get it starting to be ready for screening, where we're going to try to drive that down in the 35 to 40% range. CN ratio, everybody talks about your greens and browns, greens being the nitrogen, browns being the carbon. And we usually do measurements. That means you have to go into laboratory. We're going to try to keep it between a 25 to 1 and a 40 to 1, even though anything between 20 and 60 will compost reasonably well. We're going to get better results if we can stay at the 25 to 30, upwards of about 40 to 1 if you need to conserve more of your nitrogen. There is also a carbon to phosphorus ratio. Um, it it can be anywhere from 70 to 250 to 1. But what we're looking at is trying to keep it between 120 to 1 and 240 to 1. Great research talking about how that'll conserve ammonia. It'll reduce ammonia, reduce nitrous oxide emissions, which are greenhouse gases, and it's going to improve the quality of your product and make the microbes much happier. There's also a carbon to potassium ratio we don't usually talk about or calculate. It's usually there enough, as well as the carbon to sulfur ratio. But if there's ever a problem, analyze for those things. Say, does this run into the right ratios? And try to adjust things by having other products put into it. And probably another hot topic is pH, 6.5 to 8. We're going to try to get it there as soon as we have control over the material. So what is bulk density and free air space? We're going to allow enough room so that air can be inside the particles, and it's going to improve our bottom line because you can push air through with less cost, less back pressure is required, reduces your turning frequency, and it really reduces, well, it does have an impact on your infrastructure investments because you don't need as much air. If you bulk it correctly, you don't need any forced aeration for many mixes. So while this might be an added cost on the total volume, if that's a good quality bulking material, you can actually add revenue on your bottom line and product. Things like coconut coir, certain types of sawdust, there's a whole slew of things that you can look at that are actually desirable, or even ground bark that might be desirable in the end product that you can use as a bulking material, invest in it up front, have it be part of your mix, and improve everything in the product quality. Moisture. I spent $800,000 just getting water to a site on a project back in 1999, and it was worth every penny. That facility's still operating well. Managing for moisture is probably the best investment you can make in site development. The second best being electricity and getting that valued in there so you can improve efficiency on your operating equipment. But managing for moisture reduces your footprint size. It increases your ability to make an efficient composting process. And one of the nice things in recipes is we can use feedstock moisture as a design tool and incorporate it at the beginning, so it reduces your overall water needs. And then finally, the nutrients. Nutrients are allowing the piles to break down efficient. It's really going to manage odors tremendously, and it's improving your product quality. We're going to be conserving most nutrients unless you have your pH off being too high. You might lose a lot of ammonia in the process, but in this step, in this process, we're going to put in admixtures to make sure that we're at a pH which will typically conserve nitrogen, which is at about 7 or lower. So how do you take all the information you're going to get and try to figure out whether you've got a decent CN ratio? Cornell has a great website. Washington State University has spreadsheets that a lot of things are based on. Our company actually based our design calculator on the data that was provided by Washington State University. The composting handbook was the source, the original one, but the newest version is the composting handbook. That is this bad boy. Please get this if you have a chance. Editor was Robert Rink, and very good work. The other one out there, Wanu has on their website another good calculator. We're going to look at what a calculator looks like and how you use these things. There are videos at Wanu and um, at GMT site, and you can look at what you're doing. So here is a typical sign. You would actually identify what feedstocks you want by clicking on a button. You can take a typical number, or if you actually have your own information, you can add them into the data files and feedstock lists for what you're doing. You put them in by weight or by volume. You can set it up as a volume or a weight if you know the bulk density of your material, which is essential. So you put in the weights of the different things. You say, I'm probably going to have this, and you just hit uh, put a change in. These little dials will change, tell you whether you're within the green area of where your desirability is, and whether you should add more wood chips or remove some food waste, or what gets you to that. You can save that recipe and go through. This is what adding feedstocks looks like. Basically, you can add a feedstock here, and it'll pop up a blank screen. You can name it, put it in, and get it in there. So your actual test data can be used in any of these calculators, but you have to enter it into their spreadsheets. So one thing about carbon and nitrogen, carbon can be any of the things that I'm listing here, from syrup to bones to sawdust and wood chips, paper, leaves, fish. The stuff on the left of this line is easier to degrade, and it gets tougher and tougher as we go down to a point where this lignin may not decompose hardly at all, and it'll help develop some of the humic acids that are so valuable in compost. So realize that if you have a sand ratio, you also have to think about what is the biologically available material. And I like to use feed analysis, which is what we use for animals, so that if you were to send a sample and said, give me a feed analysis, how much of this is available for the digestion tract of an animal, they'll give you a report on that, and it gives you a percentage of the carbon that's actually digestible. So here's the bottom line. You have to test your feedstocks to know anything about them. Even though you'll have some rough parameters, remember, these are numbers that we've developed for people who are willing to share their data, went to the extension services, and then they published it. So get your information, calculate any other materials you need, get those tested, because not all sawdust is the same, not all wood chips are the same, and then know how available they are to you to purchase if you have to purchase, or to grind and manage before you're going to invest in your system. If you don't do this, you've really missed the biggest business factor in compost market development. We're going to jump a little into the process flow. And remember that with a plan, you can minimize handling and know where your best investments, your next investment, is going to be within a facility that's growing, building, and going for the gold. So very first thing I do in a facility is I develop a mass balance. That mass balance could be on a spreadsheet. I'll show you one here in a second. But you have to know what kind of tonnage you're get month by month. You want to know what your mix would be. So do your work, get your mix analysis, identify those peak tonnages. If you can't find a peak tonnage, let's say it might be 3 times the amount you would normally get on an average, or it might just be a big seasonal number. You need those because we have to design space and flow and equipment to handle those peaks without you stretching out or having to hold on to materials too long. We're going to look at the process volume reduction. This is usually based on experiment. It's fun to do a backyard size pile of the feedstocks you're looking at and measure your volume reduction at different stages. And keep that in mind. Then you look at how much holding time you need in each part of the system. So for feedstocks, we usually 2 to 4 days, and composting 2 to 4 weeks. In curing, 2 to 4 weeks, maybe 5 weeks. Product storage is really the big one because you don't, if you're in Alaska, your market timing is very different than if you're in Florida. And you have to understand when people will be buying stuff and design product storage that actually works for you, and your markets. You need to estimate pile heights, and that determines whether you need to use forced aeration, as we're showing here. You can see the air coming through from the floor through the pile top, and these are 10 to 12 foot tall piles. So if you can only handle a 6 foot pile, you might not need the forced air, but you have to estimate where you want to run and how effectively you can manage the conditions in the pile at different heights. And then we need to model these scenarios and put them into a spreadsheet. So this is a typical mass balance that's used. Typically, we look at the inputs, in this combination, some recycled wood, some new ground wood, some biosolids going into a mix, and we list out the tonnage. I like to put in the volume or the bulk density at each stage. For instance, the ground wood before grinding might be 5 times bigger. The biosolids will be the same size as it came out of the digester, and the pretty much the same for the process returned wood. So, look at how big of a space you need here, mark it down, what that ton per week, ton per year, and ton per day numbers might be. And then with the mix, how big an area, how long is it going to take you to mix, how long is the mix going to be sitting in this pile, then onward through a primary aeration, secondary aeration, curing activity, and then your screening activity. Lay it out, do the work, measure, say, I need this much footprint, and let's get it into a good design. Once you have those kinds of things together, we're now going to do the key steps of effective facility design. One is that feedstock characterization. Then you're going to look at your market, not markets just for sale of finished product, but markets for, is anybody going to be bringing in material? Do I own my own material? Do I have control over it? Those kinds of things have to be understood, and it's part of your risk factor. Now start looking, now that you know the size and scale, what do your regulatory requirements ask? We're going to cover this in session 3, but different sizes have different requirements of regulations and might have different costs for you. And then you need to look at your site. You look at a site and say, geez, I can put so much material through this. And look, I can expand over here in this area on this side. Maybe, maybe not. There happened to be a freeway or a highway going right past, so maybe I have to go to the other side. Really understand your expansion and your future, and look at your neighbors and how far away they are, and that might drive what technology you have to choose to manage the process. Do your mass balance, do that sizing exercise at each stage of handling, and then put together a master plan for this process flow and how that works on that property. And now we start developing the costs. Okay, what needs paving? What needs a compost aeration system? Where do I put the equipment? What does it run to put in the conduit underground, and all those cost issues? That's when you're doing your revenue in your cost model. But now you have to go through phasing which different technologies and what margin of safety you need for the market exposure that you've got and the environmental impacts that you've got. Some facilities are fully enclosed because they want to survive and exist, and that had a higher cost. So when you're doing a process flow, I'm just going to give you a schematic because it changes for every site. But some of the areas you want to think about are your waste drop-off areas. How are you going to get it? How many trucks might come in at a time? And make sure you have it positioned close to where you're handling it, so you're not picking it up and putting it in something with a long travel distance in between. Where your grinder is going to go. Remember, grinders have dangerous things flying out of them at times, shredders or grinders. And where you would do it. Once it goes into the grinder, are you going to be able to sort it? Are you going to put it on a conveyor system, or just pile, then pick it up, put it in another one? Each time you touch it, it costs money. We used to say 50 cents a handling. Find out what your cost per handling is under current market conditions, and say, hey, if I reduce this step, I can invest in a conveyor and that makes me money. Look at your primary screening area being right next to the mixing areas. And your raw storage, if you need to add materials like wood chips, you might have to cover it, keep it dry. And then look at, okay, everybody thinks of the technology as the composting. I'm actually going to ignore that during this session because so much more is important than just what technology you're using. You might have to manage for air intensely because your pHs are low in some aerated bays, and then go into perhaps turned windrow for the rest of the composting and finally curing, deciding what is where next to each other, and think of the flow and reducing the time that it takes to handle things by looking at effective flow, having a center area that is for activity and having these things in kind of four sides of that box, but then figuring out how to expand that effectively too takes a lot of creativity. Put it your curing next to your screening and your storage. The thing is, we don't want our fresh feedstocks next to our finished products. So think of a little bit of distribution about making your feedstocks coming in downwind and move upwind if you have wind direction. Same with slope. Put your fresh feedstocks down low and your finished products up high so you don't get water cross contamination either. So it's going to depend. And this is why we dive into feedstock so importantly. I can't compost this large pile. I can compost these wood chips. This manure on its own might compost just beautifully, but this one certainly won't, the biosolids. This one might compost just fine on its own, but perhaps it's too high in pH and it needs some adjustment with something that might be acidic. So how you do this really depends on you knowing what you're going to accept and how you're going to manage it. Bulking agents. I'm telling you, this is your people say, oh, I'll just put in wood chip. Well, this is what wood chip looks like. And then you have to put in cost of pulling out that hose, finding that hidden rebar, pulling out the nails, getting it to a product size that looks exactly like this pile back here. And here's the recycled stuff that I screened out, and try to keep it as clean as possible. So that means you've got big space issues to make little piles, and you've got to reuse this, and it will be available for reuse. But if there's other contaminants, you might have to waste that material. So think carefully. Is it cost effective to buy this from somebody who's going to make it, get into a contract and say, this is my contract price, and put your model around that? Now you have to have a location for receiving this. You have to have a dry storage area, and you have to have a location to blend. You're always going to have a location to blend. And do you really want to grind your own? It might take a different type of machine, which can be anywhere from $500,000 to $1 million for large scale equipment to process this and everything else. And once you have your bulking agent and materials, typically we have these nitrogen-rich wet feedstocks. It might be digestate coming out of a anaerobic digester. It might be dissolved air flotation out of a fat processing operation, blood and fat. It might be just food waste mixed with other garbage and contaminants that might be decomposable products or might not. So we like to put down an absorption bed. We like to get the structural materials put in directly, immediately, so they can coat over the bulking material. You want to do this on a slope that you can manage, and we're going to try to maintain our equipment so that we can get everything picked up. So they make rubber cutting edges that scrapes up, lifts up the material, gets it all well blended in. And I can tell you, operators hate those rubber edges, but they really make for a better, cleaner site. And you don't have these puddles of goo everywhere around. So that's how I know they don't have one. All I see are tire tracks going through goo. And if you have the rubber edges, that's squeegeed clean on every pass that they drop their bucket and just move towards the pile. You want to blend and aerate. Loaders do not do the best job of blending and aerating, and we're going to cover a bit of that. Other ways to think of liquid waste stream is keep them liquid and use pumps to put it out. Over at Dirt Huggers, they had 3 different basins for handling surface runoff and they ended up using it for their tankers, they ended up getting and set up with actual tanks on site so the tankers could unload there and then they could keep it as a liquid and pump it directly into their irrigation system. So these are, you can mix it in a pit. That's what they did here in these pits. Or you can actually just dump it on the top out of a tanker. You can pump it directly into a irrigation hose at the end of your turner or your mixer. So let's talk a little bit about having the plans that you need for receiving these things, storing these things, and processing them. So number one, it takes equipment. Always start with equipment you have, whether you're a backyard composter or anything else, and then you build up from there. And if you can't use the equipment you've got and you need something, then find the size that is appropriate and scaled correctly for your initial stage of operations where you know you can make money because you've done all your homework on the on the planning. So almost everyone needs some way easy to move material. Get a loader, get a bucket, put a proper edge on it. Think of getting a tilt rollout bucket. Uh, if you have a truck for delivering product, you now have a potential compost system in that you can handle materials coming in and you can handle the materials going out. Everything else in between is going to cost you more, and that might include windrow turners. A turning system that you can add to a bucket. Basically, you dig a whole scoop out and then you let it run up against some beater bars and it mixes and blends for you. Here's a tink or a rollout bucket that uses the ability to move material higher, build taller piles without driving on it. Here's a side discharge turner that goes onto a tractor and they back up the tractor through a pile, taking off about 9 to 12 inches and fling it off to the side. And I usually like to put a watering system on this so you're pulling a hose along with you. This is another type. It's driving backwards into that and throwing it off to the side, carrying water behind it. You can see two different mode. There's a Willibald here, track turn, and then the Dopstadt uh, type of turners. There's other alternatives too, and these are straddle turners. If you have a lot of space, you can have room for a tractor to run alongside, and this drops down over the pile. Needs a little bit of room on the other side for a wheel. So you can put two windrows kind of close together in pairs and run down there and just turn it in place. The challenge with that is if you have an aeration system, you have to clear out the aeration system not every time you turn, but actually once each batch is moved on and off that one location or windrow. This is a side turner, a little more detail of that track turn driving in, and they can also do this so that they can double up piles at one point, which is kind of cool because you start off at one height, material shrink, and then it makes you more efficient to not have to do anything. You can turn these piles once a week and these piles every 2 weeks. So it's actually less work and still get the same amount of work done. Just keep moving it sideways and have better efficiency on storage. Here's the type of shapes you can think of in your design. A trapezoid shaped pile uses a side turn. Triangle uses a straddle turner. You can do windrow turners that are straddle turners that are very close to being side to side. They just have a little plow in front of their wheels. And you have the ones that actually do side discharge, and either by speed of the conveyors or you know how they're running a beater flap or a spinning wheel, you can join piles together and throw things farther, all of which improves and reduces your handling cost. So the next issues are grinders. With grinders, we are making a serious choice of, do I have clean product? And if I have clean product, a grinder is a high-speed, fixed knife, big grate underneath. I'll have a good picture of that here in a second. And that beats stuff and fractures it and blows it apart, works great on drier materials, works well on stringy materials, and it has very high production. Um, shredders, well, shredders are much slower, but they do less damage to the material. And if you have high contamination levels, doesn't make small bits out of those large bits of contaminants, and they're much easier to clean out, make a good quality finished product. But everybody then says, well, what do I do? What size of grate should I get? Talk to your vendors and ask to go look at it and see if they're breaking stuff apart. Have them show up on your site. Say that pile there, I need it to run it with a 4-inch, a 6-inch, an 8-inch, and let's see which is our best production. And how fine you grind is really a big factor of how much energy it takes you to add air to a pile. So the bigger the particles, the easier it is to get air. The smaller they are, the faster things compost. So most of the time, your particle sizes, it's going to be in the energy cost to grind. You want to get it down to a 2-inch size. You're using a lot of horsepower to get it down from an 8-inch down to a 2-inch particle size. The finer grinds mean you're going to compost a lot faster. So you have a high efficiency forced aeration system with good turning and rewatering. You can handle the finer grinds and get to a finished product faster. It might require more aeration energy due to that lower porosity. And this is what I promised on the grinder. This is a 6-inch grate. This is probably the most common size used on fixed knife grinders. And these mills are just robust. Each one of those little hexagons becomes a cutting piece, and things are just blasted against it. And they have to drop outside of this chamber. You can see that they just open the chamber, but things would drop out here and drop down to a conveyor. They're expensive, but they turn what most people consider a waste into something that looks beautiful. But again, don't mill it. Don't get it all these little pieces of plastic now mixed in with all the good stuff you're trying to produce. And so think about packaged materials with other systems. Focus on low speed shredders, low speed turners. Some turners work at a high tip speed, some at a low tip speed. Keep your contaminated streams separate from the others until you can pull those contaminants out and then add them back into the other materials. Remember, any milled plastic will get into your fines. So practicalities and safety issues. You do want to be able to inspect loads, and you always want to have a contract that's going to allow you to reject a load or charge for higher levels of contamination. You're going to want to put in a pre-screening system if you have high contamination. Here they used a shredder, went into a 3-inch trommel, and then here's a duplicate line that went into a sort line. So they sorted the overs, they looked at the fines for contamination. They took all of those materials, looked at them, made sure they didn't have glass products. 3-inch openings seem to work pretty well. Here's a shredder also, kind of a makeshift operation where they then inspected it. This then changed into a different system, but there's ways to pull materials out and keep your people comfortable. This is a no inspection mode. DPACs are used for packaged waste, preferably consistently type of packaging and large batches, and it makes a soup out of the stuff that comes out of the packages, and the packages go in pretty much broken up, but in the garbage and not in your DPAC waste. Another thing, once you have that slurry, we need to reblend it with the other bulking materials. And this is a pug mill. Basically, you put in 2 materials on a conveyor and put it in. You can add your dry material in, and this just beats it like crazy. And dropping out the other side is the beautifully mixed material. You can do a vertical mixer. You can do a horizontal mixer. We've adapted these things from farm equipment. So even if you have a manure spreader, you can use that as your mixer on a startup stage. And there's a lot of those available as used farm equipment. Consider some high carbon wood ash or lime being added at this point, and then immediately after mixing, put it onto an aeration system or into a properly bulked up windrow without aeration. So the last pieces of equipment that we have to seriously understand is screening. And first you have to get it reasonably dry, and consistently dry is best, so you can tune these things in to get the right amount of product coming out and all the contaminants going to the back end. Your overs typically, no matter what, will have some level of contamination. So we add wind sifters to the back end. They have an air knife blowing air up coming off the overs. It goes and it's grabbed by the blower and put into a drop box with a screen over the top. And you can use vacuums directly over any point on your conveyors. There are systems out there that provide agitation rollers that bounce the material, so they're a little more effective to pull up with a vacuum. Nothing is 100%, so have a way to manage this. That's outside the scope of what we're going to be talking about today. So to prepare for ideal screening, you need a process in your system that's going to allow you to achieve it. You want material between 35 and 40% moisture. You need to protect the piles from the weather if you're outside, or provide a roof. You can use fleece. This is geotextile non-woven material that if it rains and you have a window shape, the water will follow the fibers down to the outside. And as long as you have good drainage between your windows, it'll run to the backside and out of your system. And it'll keep this material drier. You might have a few pockets, but typically, for instance, like this wet edge would be an issue. But well-formed piles, fleece works really well to maintain the moisture that you had before. Membranes also work. If there's a big rainstorm, the membranes are porous and they allow air to CO2 to leave the piles. You have to use a forced air system to get it to work because they're tighter, but they definitely keep it. But the challenge with those are they also keep moisture inside. So it's a benefit, but you're going to take the cover off in the dry weather, allow it to dry to get it to the ideal screening moisture. And a roof, obviously, but they're real expensive. So contamination, it's inevitable. What kind it is and where it comes from matters. You want to keep it away from even coming in, if at all possible. And once you have it, though, you have to manage anything that might be blowing off site. You have to keep things clean and you have to deal with it so you can make a good product. So having an education and communication system, no matter what, you have to plan for your feedstocks contamination and try to reduce it and make a good product. Screens really are a tool. They are the biggest choke point in most compost facilities. So if you're going to invest in a big piece of equipment, this is where I invest in it. In this system, they did two screens. They had a fine screen and they had a coarse screen. So materials introduced up here, the fines go into one stockpile, the mids go off into another stockpile. And they'll see a little bit more contamination in that. The fines typically, if you've chosen the right screen size, it might be anything from 3/8 inch, 5/16, somewhere around there, up to about a half. After a half, you start getting into what I would call mids, and you're going to see more contamination in it. And then the overs, they have to manage as well. Overs are usually managed using the wind sifter, so they get the fines, beautiful fines out. The roly-polies come off a screener, and then all the overs are subjected to an air knife going in, a big chamber where it can float, and a suction device going into a drop box for the plastic that's floating. So you have rocks and small roly-poly things, your semi-clean overs. You can still see there's something in it. But look at how beautiful your compost can be if you're actually keeping it fine enough. If you're a small system, we look at these flip screens, and a flip screen can be had on any kind of equipment that has a hydraulic system. These are run, they grab into a pile, then it rolls backwards and anything that's fine comes out, and then it goes over and dumps any of the overs that are kept inside the bucket into a separate pile. They're cheaper, they're slower. It's still going to screen and make a product though. So these are the types of things you think about scaling up. All right, 5 more minutes here. If you have fines that are contaminated, let's say you're going to handle digestate from ground up municipal waste, or you're handling garbage coming out of a mixed municipal solid waste composting facility. These are essential. They're called destoners. They're from the wheat and grain industry, and they expect to have a consistent particle size going into them. They introduce air to the bottom. They have a shaker deck, which is actually little stair steps. And as they do this, heavy particles are thrown upwards, and fine particles are just going to float on that cushion of air down, and any plastic is going to be lifted up into the airstream and collected per usual. Great. They work very slow. Usually places that have reasonable tonnage will have 4 or 5 of these destoners working to keep up with their screening operations. But again, it is possible. This is not at the small scale. So something to know that is in your toolbox. And then have personal protective equipment. Keep people happy. Provide muck boots, dust masks, face shields, gloves that can handle sharps, because there are sharps in things. And coveralls, have things provided, bibs, whatever are needed to make life good and clean and safe. Have your facilities have hand washing stations everywhere, have eye wash stations, have showers, locker rooms on site, and laundry equipment on site. These are things that really make a difference to keeping employees. Don't let them take home the smell. If they're going to use their own vehicles on site, have them park away from the facility and walk to where they're working. Give them a chance to clean up before they're going out for breaks, for lunch, and for going home. So there is one more thing that we have to manage, and that is water. I like to design compost facilities that have the ability to be zero discharge. Zero discharge means none of the water leaves the site. You're reusing it for the initial stages of composting. Since composting is a thirsty operation, unless you start with very low energy feedstocks that are already quite wet, let's say sewage sludge, then you might not be able to use too much of that water, but you could use some of it still. And you might use it later in the process than in the beginning. If you had true stormwater off your site that wasn't in contact with fresh compost, you might be able to take that pond that handles your curing compost area and introduce it back into the curing stage. But you're not going to take any of the leachate coming off your primary pads and put it into your curing, because you've met all your time and temperature requirements in that area. So water stored during the rainy periods could be used later when conditions are dry. Excess water, though, will have to go to a wastewater treatment plant, either by pipe or by truck. Or you have to have your own operation on site. And that's kind of the bottom line. I haven't seen anybody dodge that bullet any other way. The one way to make your water cleaner and your aeration requirements in those ponds less is to have a sweeping system. First of all, scrape the floor. Use those rubber edge buckets. Use a construction broom like shown here and sweep it daily. Incorporate the edges of piles into the center of the pile. So you have that little tapered edge. Don't leave it there. Scrape it up. Leave about a 1 foot nice scraped area. Then you cover your pile so that it looks nice and neat and clean. Look at these beautiful piles. Visual cleanliness makes people happier with your odors, no matter what they are, whether they're good or bad. So if they see this, they say, oh, these guys care. This is a good operation. And all they did was clean their site up, put over a nice biocover over the top, and have an aeration system that they could physically see. Check for any exposed food, cover it with amendments, and try to reduce any likelihood of scavengers, both birds and bats. If you have odors, let's say a system breaks down and you're having problems finding bulking material, have a backup plan. There are reactants that you can add to the surface pile. They'll give you 3 to 5 days of odor reduction from the surface of piles. Use biocovers, which is your own overs being reused over the top. Make sure it's moist when you're using it. 6 inches of unscreened finished compost, or 8 to 12 inches of wood chips or screened overs. There are masking agents you can use, but most people dislike the smell of the masking agent. So I like to look for reactants when I'm shopping for general odor sprays to help manage systems. There's some good companies out there these days that are doing that. And then stop accepting the problem if it's coming in. Have it out in your contract for when you have a problem. And let's reduce each time you touch things. Go through, plan your systems, lay it out, say, I'm going to move it from here to here. Can I reduce that? After maybe 100 feet, your loader is no longer a cost-effective tool to move material. You might as well be on a conveyor system. Each touch involves a time that you can add water. You can uh, you can inspect it for contaminants. You can, once it's on a conveyor, there's a lot of things you can do with it. Try to combine those actions. And last but not least, uh, here's the last key material you have to manage, and that's your air. If you have odorous material, and this site was one I built in 1999, where these trees are now all houses and a high school and a medical clinic and a dentist and a shopping mall. And I'm not exaggerating. That's what's in these trees now. Those trees are gone. Uh, and this facility's been operating in a quickly developing suburban environment. We knew it was coming, and we decided to go all in a building. And we had to build about an acre of biofilter outside of this unit. We had a watering system to keep it moist because a biofilter is nothing but organic substrate that microbes can live on, and you're feeding it stinky air. Those microbes are getting the stinky air because a moist surface, that odor touched a moist surface, said, oh, I like moisture. Most odors do like moist surfaces. And then they swam around in the water until it dried out and then it flew off. Well, if there's microbes in that thin water film on the biofilter, they're going to digest it. Simple as that. So our biofilters are typically 1 to 1.5 meters deep, so 3 to 5 feet deep. We've made them as high as 6 feet deep because they do settle over time, but we keep the free air space really high. It's made from ground wood, so it lasts a year to 2 years, maybe even 3 years. And we like stump wood. So land clearing debris, I keep that totally separate and say, I want that stump wood for my next biofilter. You can also use the finer material out of it. We usually try to keep fines out so that good airflow, good water flow when we're irrigating it, so that when you water the top, it just doesn't go into a narrow path. It kind of spreads out and gets everything evenly moist. They have to be kept moist. The volatile organic compounds will adhere to that moisture film. The microbes will develop naturally. It takes somewhere between 2 days to 2 weeks to get a biofilter to start being very effective at the top notch of its performance. Usually in 2 weeks you're there, but before that you still have good effects. And they can scrub upwards of 95% of odor compounds. Typically they're rated at 80 to 95% as their range, and I've seen them perform even better than that. So have an irrigation system, screen out the fines. You might have to go in and work that area. So I like to have accessible site for my biofilters. And remember, there might be short circuiting. Design it well. Don't put any aeration out near the edges of it. And you're going to see back pressures on your blower system, which is a cost of about 1.5 to 7 inches water column as it starts, and then it degrades and settles in, depending on how the air is getting there. So this is kind of it. That's my spiel. Biocovers work, biofilters work. I didn't cover biocovers as well as I usually do, but most all of us use biocovers, and I look forward to questions.
All right, thank you, Jeff. As always, a great presentation, great content. So we're now going to go into our Q&A session. So if you have a question or a comment, please use the Q&A feature on your computer. And we have quite a few already. So, but I'm going to start out with one that I guess was the first couple of slides. You had the the chemicals there that were concerned, sulfur and phosphorus.
Potassium. Yeah.
What does feedstocks typically have those elements?
So phosphorus you're going to find in manures typically. So if you're low in phosphorus, let's say, try to find a source for manure. That's an easy win, typically, depending on location. Sulfur, it's in almost all materials. Phosphorus is usually in most organic materials too, if not higher. I've seen that some research has shown that with phosphorus going into, I think they're doing uh, composting of substrates where they were a little worried about seeing, well, does phosphorus help? They added 2.5% by dry weight of superphosphate and had great reductions in ammonia as well as nitrous oxide. And they also had a better product. So thinking of those balancing points, find the research that says, yeah, this is going to work. Get the data, talk to someone who actually understands what's going to happen in those ideals. Use the calculator, say, am I close? If I'm not, is it a problem? Not necessarily. But that's what I do. If you want to use a chemical, superphosphate works. Phosphogypsum, I believe, works somewhat. Um, if things are too acidic, you can add uh, wood ash or something else to bring the pH up. But remember, those things have their own costs. I like to use frilled gypsum, which is calcium sulfate, and have that be used as a amendment to acidify chicken manure. And I'll use about 1.5% by dry weight into the mix of the chicken manure itself to get it knocked down in pH so it's not blowing off huge amounts of ammonia. So all these things have a cost, they have a value. You need to look for sources. Sulfur, I use the calcium carbonate, I mean the calcium sulfate to do that. And it added enough sulfur. It didn't get to be a sulfurous odor. Most anaerobic digestive materials have plenty of sulfur already in. Next question.
Thank you. Okay, for storing browns, why a dry area?
Oh,
Wouldn't it be
well,
good to have fall leaves or wood chips absorb some moisture?
absolutely. Thank you. That is the best observation. It depends. If you have a very wet material, you use that dryness to reduce the total cost of bulking material. So if you have a very wet material, let's say it's 75% moisture, 85% moisture in that range, you might not want to have water on that. You want to give it time, use that dryness to absorb some of that excess liquid. Whereas let's say you have something that's only 70% moisture, 65% moisture, yeah, it makes sense to have that bulking material be wet or be moist so that it doesn't dry it down too low where you now have to add additional water. Plus, softening up that wood, making it more available to the microbes as a surface to live on is always a great idea. I love using recycled overs, except for the contamination in them, uh, because it's already pre-moistened. It's already a great host environment for those bacteria, and they jump in there and they start eating whatever it is that's new and available to them. Whereas a hard wood chip needs time to soften up, expand out, have more surface area available in a microscopic level, and stay able to give and receive water and moisture. So yeah, I agree. I like pre-moistened wood chips better than I do dry wood chips. They function much better. It's something you want to do, but don't overdo it. And having control over the piles by having cover or a storage place gives you that control.
This is a question. Did you call it a pug mill?
Yes.
PG. Yes.
PUG.
Yeah.
Yeah. Yeah.
Basically a
Uh,
mixing mill, correct?
it's a mixing mill.
Yeah.
You're dropping material kind of in the upper side of the chamber. The chamber itself has a shaft with beaters on it, and it's got to go from this side to this side, and things just mixing it like crazy. And it's great to do inline on a conveyor if you've already got it onto a conveyor. Let's say you have freshly ground material coming off a grinder, you have a way to put the sludge on top of that, and then it goes right into the belt mixer. Nobody's touching things twice. And that's been done at some pretty cool facilities like Inland Empire. Did something similar to that. I'm not sure if they use pug mills, but that was in our original design for that facility. Um, it is a good technology. It works. It's durable. Otherwise, you have to pick up the different amendments and get your bucket all dirty. And um, at some point, it has to be in a feed hopper. But at that point, man, the world is your oyster to have it, add water, mix materials, add amendments, do everything you can once it's in line with that system. And if you're going to go from one area to another, have a watering stage as it's coming off the last belt, so that if you're going between stages, all these things are really useful.
This is an interesting question. It comes from Mexico,
Oh,
uh, and it has to do with a waste that they want to compost. It's an agave-based waste.
I'm
Uh,
familiar.
okay, it's
Yeah.
reject. It's from reverse osmosis bioreactor for composting. These contain salts and heavy metals, and
Okay.
it's a sludge material. So that sounds interesting.
It so the heavy metals are in everything. The question is, are they concentrated enough to be of concern for the user? And in the US, we have standards for heavy metals that are based on if a child eats this material over, every day uh, of their life, what's their risk factor? And so those safety factors were built into. There was other safety factors in there, but they looked at what those might be for a wastewater treatment plant solid and what that availability might be. Your material's closer to that than most other feedstocks I've been hearing about or dealing with. And those standards are published under the EPA 503. Um, uh, I could give you the different tables, but they have the total metals table. I think that's table 3, 40 CFR 503. I should be able to give you the whole thing, but it's really column. We just call them what is the EPA standards for compost and biosolids. And those metal levels, if you're below that, it's not a problem. So the question is, where are you? Yes, we all have heavy metals, and where are those numbers and how do they act with each other? So bear in mind, the world is a dangerous place. If you have salts, I'm actually more concerned about your salts than I am about the heavy metals, but I haven't seen your test results. Test for it. If your salts are quite high, realize that if somebody's going to use your compost, they might have to have irrigation, be significantly irrigating it to drive those salts out of the soil profile in the initial stages, but they're also going to lose a lot of your nutrients. So salts are a challenge. If you can remove salts from any part of your process ahead of that, would be ideal. And we're talking about sodium chloride salts, not nutrient salts. Nutrient salts are great. So remember, we're worried about table salt or sodium chloride. That you can get in your test of your feedstocks.
This is a biofilter question. Do you compost a spent biofilter when it's replaced?
Oh yeah.
Stump wood is an interesting resource, but I understand it can be high in pollutants. In that
What
case,
pollutants?
perhaps not great to use as a bulking agent. Yeah.
Never heard of that. If your soil is polluted, yeah, they can be, but I don't see how a stump would be any different than a branch than a leaf. Um, that the only exception being the soil that was around them. So if you have dirty soil, yeah, don't take it from a Superfund site, definitely.
Or they don't
Um,
dump stump, as long as they don't dump stump rot on it. The chemical.
right, chemical. Yeah, there are issues with any feedstock, and you have to know your product. And if you think that's an issue, test it, find out, look at the numbers, ask somebody who's an agronomist to say, is this a problem? And get that real data. What was the second part of that question? There was
Yeah,
something
well,
else.
there's two here with how often do biofilters need to be replaced, and
Ah,
can
yeah.
you compost the spent biofilter material?
Biofilters can be replaced anywhere from a year to 3 years. And typical recommendation is every 2 years, but it's based on the back pressure that forms as things are coming down. So if you design a lot of uh, pressure capability in the blower you've got, you can last a very long time. Some at Dirt Hugger were that I saw. I don't run the plant, but I said, "How old is that one?" And they said, "Well, that's our original one. That was 5 years later, still working very well and performing well." But they had the blower power to overcome the back pressure. So it's based on back pressure, what your blowers were designed for. The engineers who designed your biofilter should be able to tell you, we can handle up to about X amount of back pressure on that, and then monitor it. I try to monitor at least quarterly on back pressure to see where it's trending, and then I can accumulate my material and do it. So the question of reuse, man, biofilter media reuse, it has always high nutrient. It's going to be richer in nitrogen than your normal compost is because that's where the nitrogen accumulates. And the
Good.
microbes love it. It's killer stuff. I have a friend who wants to make those into biofertilizers. So it's uh, it's a good it's a good product, and don't just throw it out. And you can compost back in, won't hurt it, but don't waste it if it does have value. Again, test your products, not just your incoming feedstocks. And biofilters are a product.
Any recommendations on mixtures for shredded food and yard wastes, vertical versus horizontal?
Uh, there's a lot of benefits to both. I've used vertical and I've used horizontal. They both work. Um, I think the challenge I have with uh, a horizontal is I see that it kind of gets more clumps in it. Um, it kind of stays packed, whereas a horizontal keeps a cascading activity happening. It has a big screw, lifts the material up, has cutters on the outside, and it's a cone of flight. So it just lifts and throws, lifts and throws. And that seems to get us some good circular motion. Um, and it's got a great big open top. They both do. You can put it in. I don't know. There's not much benefit one way or the other. It's really what's your mix ratio and what are you trying to get away with? I love horizontals for sawdust type mixing with a lot of fines in it. They seem to do a good job. They're turning and moving things two different directions laterally. Um, and they both discharge out of a chute and then onto a conveyor. And once you're on your conveyor, get it into your compost pile directly is best. Sorry, I can't make a decision for you. I like them both.
Okay. This question is related to biochar. I guess you might want to explain what that is, and then
Uh,
is it good for the composting process, and when would you add it?
oh, that's really interesting. I'm going to direct you to Engineered Compost Systems. Just went through and did some of their own evaluations. There's a lot of data and research out there being done by scientific journals that are being published. Biochar is taking a organic material, typically a woody material, and going through pyrolysis and taking the gases that come off of that, using them as a fuel. And then you're limiting the oxygen. So you're burning it without oxygen. So it's oxidizing without oxygen. So what happens is you are left with a structural material that looks just like charcoal. It is charcoal. And the other gases, which are primary gases that can be used as a fuel. That biochar has some great uh, uh, properties. Terra preta was discovered as the method of burning, slash burning, and covering that over and forming long-term biochar under the soils um, in the tropics, where they have a very hard time keeping carbon available for managing nutrients in the soil in tropical environments. That terra preta has been then saying, well, how do we evolve that into composting? Is this of value? And the answer is somewhat. It doesn't really improve the process so much. You can use it as a tool to act as a temporary biofilter, biocover, to help improve the absorption of emissions that might come off the surface. And it also does show some value in the finished product. But I think it's best to, since it's mostly a new technology, it hasn't been really well developed. I wouldn't distrust that it's got a value. I would just make sure that it's got value for your use and your application. And we see no problems with it in a composting system. It's just there's nothing available to decompose. There's no value for the microbes to eat it as a substrate. So it's kind of riding along with your product. And if it creates a better finished product, great. And where you introduce it is not so much important, except that it might actually fill some of those voids with some of those nutrients that might be lost early in the process, like ammonia.
Thanks. All right. Can you speak more on the importance of digestibility of variable feedstocks using the animal feed testing process? We use strategies like fine sawdust mixing with wet food scraps or more moisture in
Mhm.
woody uh, parentheses high C carbon to nitrogen ratio and parentheses, but haven't utilized those lab tests to inform process adjustments.
Yeah. Um, I have not seen a good paper on this. So mine is just based on experience. Uh, let's take hemicellulose, chopped straw, that might be waxy, might be excessively dry and hydrophobic. Let's take sawdust. Those two have very different availability of carbon. One is close to what an animal will be able to eat and get energy out of. They're not going to eat sawdust and get energy out. Okay, so the BVS, biologically volatile solids, acid digestion, will tell you, hey, I'm going to get a higher percentage of my carbon on that straw than I am um, out of the sawdust. So that biologically available number is what we are trying to understand so that we know that carbon is digestible. It can be thought of in your calculation as real carbon and real availability. And there is some in the wood. I'm not saying there's nothing. I'm just saying that the relative ratios of the value of that bulking material is going to be higher with a higher BVS of the carbon than the other material. I uh, I can't say that there's a chart that says, yeah, this stuff's better because there's so many different forms of carbon. If you want to, we can go back and look at the lists. They're just partial lists. We don't have good data. People don't test for it because the cheapest way to test is just burn the material and then apply a 1.8 correction factor to that ashing number and say, okay, that's your carbon. But that's not very accurate for all these different materials. That's why I like to encourage people to do biologically volatile solids, the feed digestion, to really understand what their material is and how valuable it is. And then the CN ratios will change for what you do, and you might be able to get away with a lower CN ratio because your carbon is so effective and make a killer product that is really well done at the end without seeing sawdust at the end saying, well, you built that with sawdust. Yep, I did, because it's still in there and it didn't affect my process much. So I wish I could say that there's something I've seen out there. If there is anything that somebody's read in the research, please make it available to this organization and we'll get it posted.
Yep, yep, thank you. One time for one more question. Have you designed any facility using the Soil Food Web school teachings?
Their teachings are for product, as far as I know. I haven't actually listened to their designs for facilities. Typically, when I'm trying to make a soil food web beneficial product, I am focusing on what are your substrates going into the initial mix. I'm trying to stay away from materials that will discourage fungal activities. And I'm trying to find a curing system that allows for little disturbance and allows for time and keeping the piles cool. And there's one other thing that I don't know that they teach or not, but Tom Richards came up with some exciting research that I don't think has ever made press, and that the higher moisture your curing process is, the more fungal activity is going to occur in your material. And there's some work out of Colorado, no, out of New Mexico, the U Johnson, I think, I'm sorry, I've got the name wrong, process where they're allowing things to stay moist, stay woody, allow them a lot of time. They're talking upwards of 2 years. And then you're going to get a product which will meet these, very high humic level, very available uh, forms of carbon and highly fungal materials. Fresh compost coming off a production plant, you can turn that into the same thing by keeping it moist, holding it longer, and just making sure there's enough food long term for the fungi stage of decomposition.
Okay. All right, so we're gonna wrap up here. Again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market websites. Um, this one this will be recording will be put up on our YouTube channel very shortly. And again, those who are on now are automatically registered for the third and final webinar next month in July, July 19th, I believe.
Mhm.
So again, thanks for joining us, and thanks again, Jeff. And we look forward to the last webinar. So have a great day, everybody, and we'll see you next time.
Thanks so much, everyone. Bye bye.